Hello everybody and welcome to video number 6 in this development vlog series of game Jerboa Wars. We are still on the JSON component, the very root of our client-side graphics rendering engine for this game. And today we are going to talk about composite sprites. So we've seen how sprites work, we've seen how sprite grids work and grid sprites and all of that stuff. Today's topic is actually bringing it together for objects, more complex objects in your scene, in our scene, that combines multiple sprites and containers all under one structure. So the idea is that you have a texture, as you can see here, and then you have data about sprites that are taken from that texture and organized in a certain way, and that under the hood, it just creates a container with sprites in that container and other containers, so like a tree, a hierarchy. But all of that is encapsulated within this JSON metadata, so to speak, for the sprite. And this way you could have it, this shortcut of creating these complex objects, and then you can apply all the stuff that we already talked about, like animations and, change properties and positions, all of that stuff. So let's see. So a texture is just a normal image with different sprites on them. And you can see these are separate sprites, and these areas where the sprites are, they represent different parts of a character or anything, any composite object you would like to construct on your screen. Having all of this on one texture, we can apply an additional data that will take these separate sprites and organize them into this character that we will be using in our game. And the pipeline is pretty straightforward. So today's presentation is also going to be short like last time because there's not much to talk about here. It's just a concept of organizing your graphics data into more kind of encapsulated objects that can be reused in your scene. And we'll see in code how all of that is done, but the pipeline is this. We have a texture, which is an image. We load it as a normal texture. And then we have the sprite sheet data formatted in JSON. The same format that Pixie.js actually takes for the sprite sheet. And here the data just has definitions for all of the sprites in that texture, their positions, their size, and things like that, or the frames. And then once we have that, we have additional piece of data, which is the sprite composition data for the container, that actually takes these sprites from the texture and then organizes them together into an image in certain order and in certain places. So you can see the white outlines here show actually all of these sprites, just to demonstrate where all of these rectangular sprites are coming from. And what we have here, this JSON data it's kind of like a builder pattern where the JSON data is used to construct a container and sprites with them, maybe possibly other containers, and nest them. So it's kind of like a sub-tree in the render tree with all of that. And what we be looking today at is how this JSON data is organized and what are the classes responsible for working with this pipeline. There are very few of them, and we'll look at the example how to use the composite sprites in our scene. All right, so the code part, we just have a few points here, and the first class that we will be looking at is the JContainer data that encapsulates the serialized information about the positions of the sprite and their order and things like that, giving them names for better access, and it's very straightforward. And then, so JScene Builder is a service, that we already have. We're just going to be adding a couple of methods to it that we need, as if you remember in the pipeline from the previous slide, two things. So first we need to build the sprite grids. That is done with one method here in the builder that takes the JSON argument and builds the sprite grids first. And then once we have the sprite grids, we need to organize them into these composite sprites, composite containers, and that is the container builder method that does that. And that calls at build time, when the scene is actually built, it calls into the build sprite grids from JSON method that takes this JSON file and then actually injects the containers and sprites, all of this hierarchy, into the actual render tree on the scene. All right. And the scene itself has the container builders dictionary where we can keep track of all of these container builders for our composite sprites right there on JScene, and then call into them when we need. So for example, if we have a container builder for this mouse, but we want more than one mouse on the screen, and we will be we'll have it in the dictionary. There will only be one container builder, but we will be calling into it to instantiate the subtree in our render tree for every character, every mouse character that we'll have on the screen on our scene. So that's about it. Let's jump into Visual Studio and see where all of this is implemented, and then look at the example. All right, here we are in our project. Once again, all of this is going to be pushed to GitHub. The example page will be updated as well. All right, let's look at a couple of JSON files first before we go into the C# code. And this is the metadata that is used in the pipeline. So the first one is the one that defines the sprite sheets, where we have a texture, and this is the same format as the normal, Pixie.js sprite sheet data format, where we have different frames in our object, in our data object. Here we have the frames, and then we have the object with properties that define for each sprite that we want to include in our composition their information by their location, the source size, and all of that stuff. This is kind of cutting up the texture into sprites. And then, as you can see, all of these parts, all of these sprites, they have names. And we will be using that in the second piece, that is the second part of the pipeline, where we take now the sprite sheet and we create a hierarchical subtree in our render tree. Well, it's not. It's a data to build a subtree, and this is all of the information for the builder. So, for example, we have the container, and then the children container. We have the sprite that is that takes from the sprite grid name as shadow. The name of the sprite itself is going to shadow, and this is the position. And we have another container here, and then inside the container we have like the legs and the body, and the second leg, the eyes, and all of that is just the definition that links to the sprite grids that we've created in the previous step of the pipeline, and arranges them inside the object with location relative to the root element of our composition. So this is the data, and the classes that process this data is here. The new that we have is called JContainerData, and this is directly reads from the JSON, deserializes the JSON data into this object, and recursively builds all of the children, be it the more containers or sprites and all of that. So it encapsulates the reading of that JSON data in the second stage of the pipeline. All right, so the addition to the scene builder that we've talked about, there are a few methods here, and like just a couple of things I want to emphasize. First of all, I've added this method. It's called add sprite grids, and all it does, it just memoizes the location of the textures based on the JSON data from the first stage of the pipeline. Here we are just memoizing it, but at the build time, it will create the actual sprite grids out of the sprite sheet data. And the second method that we have here is the add container builder, which we are just linking the JSON data from the second stage in the pipeline to our scene. And then we can call this container builder by name wherever we need to in our application. And there's not much more to it here. So this method is used to build the sprite grids out of that sprite sheet JSON encoded first part in the pipeline. And all it does, it actually just adds the sprite grids to our normally created sprite grids, which is then parsed the same way as just normally defined sprite grids, if that makes sense. So this is as far as a builder is concerned. Just one more thing that I want to emphasize here is the addition of the HTTP client argument to the service as a service parameter. Because we need this, because since this is WebAssembly, this is all running on the client side, if you remember, the actual static data like the JSON files and the textures, specifically for reading JSON, we cannot read it as file as you would say with the active server setup, because WebAssembly doesn't have direct access to this server file system, right? The only way you can fetch data into WebAssembly is through an HTTP request, and that's why we need the HTTP client for that request. And the way it's used here, if we look at our when we're actually building the containers for these composite sprites, we are fetching the JSON information. We're fetching it from the server with an HTTP request, as you can see here. This is just this line here. It looks into the memoized values that we've added during the build process before when we were constructing the builder, and when we actually call the build method, that's when the HTTP request go to the server and fetch the JSON files here. So that is it. There's not much more here. Let's look at the example. And the example that I have is the new container builder test. So let's look at, again, the same pattern that we used in the previous examples, where we are creating a new class that inherits from the J container, which means this class becomes an object renderable directly in our scene, just like any other iScene object implementing classes. We are making a mouse out of these composite sprites, then we can just add it as if it was just like a normal container on the scene. But let's look at the pipeline. First, the same, we have our Jerboa scene tested with our usual event handlers on scene building and scene initialized event. So scene build handler, what we have our normal texture, which is this mouse texture, the same one as I showed in the presentation. And then from there, we are adding this texture to our scene. And here we're defining where the metadata, the JSON metadata comes from, the URL to it with the data for the first part of the pipeline that we talked about. And this is this file, mouse, which one? The mouse underscore sheet.json. And as you can see, this is a URI because the builder will fetch it with an HTTP request. We don't have access once again to these files directly because we are running this on the client side. And the files are sitting on the server. Now, and here we are adding sprite grids using this sheet URI and using this texture. And for every occurrence of the sprite grid building, we can add additional parameters, and there's not much of it. I'm just offsetting it by 1 pixel here, and I want to add additional when we are parsing the eyes sprite grid. I just want to define the number of columns in that sprite, because the eyes will be a sprite grid with different, there'll be open eyes and closed eyes and blinking and frowning, all of that stuff. It's a sprite grid with six different columns, and the sprite grids, the frame size on that grid is 32 by 29 pixels. That's the only thing I want to dynamically adjust when the the sprite grids are parsed from the JSON file. So this is the first part of the pipeline. It happens when the scene is building, and after the scene is built, we have access to all of these sprite grids already as assets in our scene. So this is where I'm instantiating this mouse view, which inherits from JContainer, instantiating the same, and then I've added this initializer method, which I call immediately after the construction. So first I construct the mouse object, which constructs the view for the mouse inheriting from JContainer, and I supply the root of the render tree as the parent for this object. So it's going to be rendered directly in the root of our render tree. But this initialization, this is where we are actually using these container builds. So this is the second step in the pipeline, where now we have this JSON container builder, which is, we defined it here with the name mouse and the URI to the assets and data mouse. This is the second JSON file that actually builds the object out of these sprite grids. And we're taking these container builders, find one by the name, which is mouse, and we just call the build method on it. And the argument here, we have the parent, where do we want the object, the container that is built out of this, out of the JSON definition, where do we want to attach it to which object in a tree, and this is going to be this under the mouse view itself. And then the second parameter is whether we want to skip the root element in the JSON or not. In this case, because we are taking all of the objects inside the JSON and attaching it directly to the mouse view, we don't really need the root. Like if I look here at the mouse, where is it? Mouse.json. You can see that there is one root element that just says container, name mouse container, and its position 0, whatever. And then it has the children. And this is the children that we are interested in. So all of these sprites that are declared here as an array, all that flag set to true means that we are just starting to take all of these sprites, all of these containers and sprites, ignoring the root element and attaching them directly to our scene object, which is the mouse, the mouse view, and that's all. So it's just like a little cleaner, and that's all. Now, and additionally, now that we have our mouse built just with one line of code taken from the JSON definition, that's just a static sprite at this point, and now we can just start animating any of these sprites and containers under this hierarchy. They're just normal sprites and containers. You can animate them the same way or do whatever you want with them, change properties, just as if they were normal parts of your render tree, which they are. All this really does is kind of organizes the construction of your sprites, composite sprites. But under the hood, it builds into just, normal subtree in your render tree. And everything is accessible, so I have some methods here that define a few animations for the blinking, the frowns, and the crouching and jumping and stuff. You can look at it. We've gone through this. This is just the normal timed action animations that we talked about, just animating certain sprites within our hierarchy here by names, and all of that is encapsulated in mouse view, where I call blink on it, the thing will blink. I call crouch on it, it will crouch, and things like that. And I don't need to worry about placing this code anywhere else. It's all nicely encapsulated within this one class. And now once we have our mouse view and we initialized our mouse view, I center it on the screen as usual, just like any other sprite. And from there, I'm just connecting. I have it as a private field on my page. And all I'm doing, I have a few buttons there at the top. We will run it in a second. That are just taking this mouse object, and if it's initialized, just calling the methods for frowning, for jumping, for whatever like else I want to add, and it will just play the animations. Very simple. So the actual code after the mouse view is encapsulated like this. The actual code, as you can see here, is like 56 lines. have I not used the JSON definitions for this composition, I could have done it manually. I could have created all these sprites, like really write it out, or maybe in the mouse view class, but that would have been a lot more disorganized. All of this does is really just helps organize the sprites in the coherent hierarchy. All right, so let's run this and see how this works. I've added the test 6 here, and there it is. This is our sprite that is composed out of all of these different parts, and it looks like it's one sprite, but it actually is not. And when I animate, I'm just animating certain sub-sprites in the tree, like sprites in the subtree, I should say, for whatever action I want. And I can do just one at a time, or I can do several of them at a time. You can see here the ears animated, the legs are animated, and the eye, all of that is encoded within those timed actions on the object itself. And now I can just take this object, insert it into my scene, and then have the business logic just call into these methods for whatever I want to do with it. And animate, add, change whatever I want inside the object itself. So, and that's about it. A short, nice discussion for today. And check out the repository, decoded the repository. Also check out the other examples online, as they are now live. Link is in description. And I'll see you guys next time. Cheers.